Hello everyone, today's video focuses on analyzing the extreme precipitation and flood events of June 2021 in Bloomington using the generalized extreme value regression. The presentation will talk about background of the Bloomington extreme precipitation events, past extreme precipitation events, impact of human activities, and future extreme precipitation events. And the last one is using GEV to analyze the Bloomington extreme precipitation events. So, on the June 18 to 19, 2021, Bloomington experienced an extreme precipitation events that lead to severe flooding. According to measurements from the station at IEO, the two-day rainfall reached 6.1 inches, setting a record from the highest two-day precipitation in the century. From the picture, it is evident that the floods caused by these events, leading to a power outrage with streets and apartments submerged, cars away by the waters, and even resulting the death of a driver. The flooding happens because of a lot of precipitation from a big storm system called a mesoscale convective system, which was stuck in one place because of a nearly stationary weather front. On the night of June 18, this storm system gets stronger and didn't move, so it caused a huge thunderstorm over Bloomington that lasted more than 8 hours into the next day. During this time, several smaller storm cells kept forming and moving over the same place again and again. These three figures show different things about extreme precipitation. The first one shows the trend of 7-day maximum precipitation. The second one shows the trend of daily extreme precipitation anomalies, and the last one compare the change in extreme precipitation between two different periods. The research shows that climate change is making extreme precipitation more common and more intense all over the United States. It could even make this kind of events over 3 times more than before. Also, studies stress that in the Midwest, the extreme precipitation is getting worse and happening more often. And human activities like releasing greenhouse gases and aerosol into the air have really changed the way it's precipitation. The left figure shows the contribution to precipitation from different human emissions, including fast aerosol, slow aerosol, and greenhouse gases in different seasons, with green indicating a increase in precipitation. The right figure shows how the return interval of extreme events change under different future temperature increase. So the research shows that these human activities are making extreme precipitation events more intense. For example, greenhouse gases causing more extreme rain each day, while slow aerosol mostly have negative effects, and fast aerosol change how they impact the weather depending on the season and area. These changes have made what used to be rare once in a 100 years events happen every 20 years now, making them 5 times more likely to occur. And according to the IPCC, human-induced climate change will lead to an increase in the intensity and the likelihood of extreme events. And in the future, the frequency and intensity of extreme precipitation events will continue to increase. The left figure compares the intensity of extreme precipitation with average precipitation, clearly showing a great increase in extreme precipitation intensity. The right figure shows the predictions for future trends in extreme precipitation based on different datasets, yielding the same results. And this is the background on the extreme precipitation in Bloomington for 2021. We got the data from IU station, and as mentioned before, 2021 had the strongest precipitation in a century. We used data from 1915 to 2022 for the analyze, and we plan to compare this with the data from 1895 to 2022 later on. The generalized extreme value GEV regression is great for studying the events like Bloomington 2021 heavy rainfall because it focuses on specifically on the biggest and the smallest value, which are often the most important in weather study. It works well because it uses long-term data to predict how often these extreme events can happen and how severe they might be. We didn't use the central limit theory for this because central limit theory is better for analyzing average situation, not the rare or extreme case that GEV handles so well. Analyze using non-stationary GEV regression on data from 1915 to 2022 estimated the 2021 events return interval at around 87 years compared to 49 years in 1915, indicating a significant shorten over the past 70 years, and the risk ratio around 3 times as 90 years before, around 7 years before. And analyzing from 1895 to 2022 shows a return interval of around 46 years compared to 43 years for 1915, influenced by two extreme events in the early 20th century that each record about 7.9 inches over 2 days. And these results show how important it is to pick the right time series data. Shortened time series better reflected today's climate risk, while longer one might be scoured by old extreme events. It is crucial to choose the right data for your study and be careful with how you interpret the results to avoid mistaken from data bias. And overall, most studies now show that human activities are increasing extreme rainfall events. Analyzed using non-stationary GEV regression based on 70 years of data show that the risk in Bloomington is now around 3 times higher than before. Future research needs to keep improving this method to better understand the predict extreme weather pattern. And this is the reference using in this study, and the code can be found in this website. Thank you.